Yeah, good evening children. So today we have to discuss yesterday's question paper, that is Neet 2024. Neet 2024 chemistry question paper analysis. Chemistry question paper analysis. The code is T3. Code is T3. Yeah, brief discussion about this question paper, chemistry question paper, Neet 2024. Right. Now, question number 51. 1 mole of H2O to O2. 1 mole of H2O to O2. That is conversion. How many Faradays require for the conversion? Actually, the basic thing is here. 1 mole of charge of electron is equal to 1 Faraday. Now see here, 1 mole of H2O, that is oxygen state is here -2, O2 is 0, that is 2 electrons change here. 2 electrons change means 1 mole of electron charge is 1 Faraday, 2 mole of electron charge is 2 Faraday we have to take. 2 Faraday we have to take. That is the reason why we have to take A for 2. Then 1 mole of MnO4 changes to Mn plus 2. That is MnO4 minus, that is plus 7 changes to plus 2. That is 5 electrons difference here. 5 electrons change takes place here. 5 electrons change takes place means we have to take what now? 5 Faraday. That is. Then 1.5 mole of Ca from molten CaCl2. That is CaCl2 changes to Ca. That is plus 2 changes to 0. Plus 2 changes to 0. That means 1 mole of CaCl2 changes to molten Ca, that is 0. 2 electrons change. But they given here 1.5 mole. 1.5 mole means 1 mole means 2 electrons, that is 2 Faraday. 1.5 means 3 Faraday we have to take. That is we have to take like 3 Faraday. Right? 1 mole of FeO changes to Fe2O3. That is FeO is plus 2 changes to plus 3. Plus 2 changes to plus 3 means 1 electron difference. 1 electron difference means 1 Faraday we have to take. Here what 1 Faraday we have to take. Right? Finally, the answer is this one. For this question. So A we have take 2, A2, B4 and C 3 Faraday, like C1 and D3. Right. This is the answer, correct answer for this 51 question. Yes. Then I move on the second question. Next question. Question number 52. Which reaction is not redox reaction? Redox reaction is nothing but oxidation reduction takes place simultaneously. Is called redox reaction. Oxidation and reduction takes place simultaneously. In one single reaction is called redox reaction. Oxidation means loss of electron, right? Loss of electron or increase in oxidation number, right? So reduction means we have to take gain of electron, or decrease in oxidation number, right? Now please observe here carefully. H2 here 0 oxidation state changes to +1 oxidation state. Cl2 is 0 oxidation changes to -1 change. So it is a redox reaction because of hydrogen loss of electron, chlorine gain of electron. It is a redox reaction. But in option 2 we can observe here Ba plus 2 and Cl minus, and sodium is +1 oxygen state here, sulfate here -2 state. Here Ba is +2 oxygen state, sulfate is what is Ba -2, and Na +1, Cl -1. So there is no change in oxidation number. There is no change in oxidation number. There is no oxidation reduction reaction. So this reaction we can take as a not redox reaction. Generally all the reactions come under redox reactions, except double decomposition reactions not come under redox reactions. Yes, that is option 2 is the correct answer. Yes. Then move on the next question. Move on the next question. Then 53 question. Intramolecular hydrogen bonding is presenting. Intramolecular hydrogen bonding. So hydrogen bond formed between highly electronegative element like fluorine, oxygen, nitrogen. With hydrogen there is a attractive forces generated between this highly electronegative element and hydrogen. These forces we are calling hydrogen bonding. Hydrogen bonding, right? Now please observe carefully. Intramolecular they are asking. Within the molecule hydrogen bond formed. That is, we can take this hydrogen, between this hydrogen and highly electronegative element like oxygen. So between this attractive forces we are calling hydrogen bond, right? Now here in this case we can observe here between two molecules hydrogen bond possibility is there. Between two molecules hydrogen bond possibility is there. Between two molecules, right? Here between this hydrogen, this oxygen. So here we can observe intermolecular hydrogen bonding, right? Here also intermolecular we can observe here, right? But according to our question, first option is the correct answer. Right? Then question number 54. Failing solution A. Failing solution A is aqueous copper sulfate. We have to take aqueous copper sulfate is the failing solution A. Failing solution B is sodium or potassium tartarate. Test for aldehydes we are using this, right? That is option 3 is the correct answer, right? Then we will move on the next question. That is question number 55. 1 gram of sodium hydroxide was treated with 25 ml of 0.75 m HCl solution. The mass of sodium hydroxide left unreacted is equal to, right? Now your acid base reaction, here it is HCl react with NaOH. HCl plus NaOH gives rise to NaCl, acid base reaction plus water, right? Here it is 1 mole react with 1 mole of NaOH and gives 1 mole of NaCl and 1 mole of water. 1 mole weight is 36.5 grams. This is the 40 grams. of NaOH require 36.5 grams of HCl require 40 grams. But here they give 1 gram of sodium hydroxide was treated with this is the 1 gram of sodium hydroxide treated with 25 ml of 0.75 m HCl solution. The mass of sodium hydroxide left unreacted. So how much in this 1 gram of sodium hydroxide, how much unreacted we need to find, right? So that is 36.5 grams require 40 grams. For 40 grams require 36.5 grams, right? For 1 gram means 1 by 40 moles. 1 by 40. Now it is 40 grams require 36.5 grams. Now here according to given data here 25 ml of 0.75 m HCl. 25 ml of 0.75 m, 0.75 m into 36.5 grams gives require how much NaOH according to given data 25 ml 0.75 into 36.5 grams of HCl require how much NaOH. Okay, that how much NaOH require, right? Just simplify this cross multiplication by using cross multiplication. Actually we have one formula, that is m is equal to weight by molar mass into 1 by v in liter, From here we need weight means weight is equal to molarity into molar mass into volume. So this one only I took here, that is molarity they given here 0.75 and molar mass is 36.5 and volume is 25 ml. Right, from here we can, so this is the formula. From here if you simplify this by using cross multiplication, 25 into 0.75 into 36.5 divide by 36.5 into you should take here into 40 you should take here, right? So if you simplify this, this one gets cancelled, right? From here 25 into 0.75 into 40 So if you cancel this point, by 100 we have to take 25 ones are 25 fours are, we can simplify like this, right? Then 75 into 40, this 4 gets cancelled, just 1 over there, so that is 750 milligrams required. 750 milligrams. Actually we have 1 gram. 1 gram means 1000 milligrams. So how much require here? 750 milligrams require. 750 milligrams require means we have actually 1000 milligrams. 1000 minus 750. 1000 minus 750 means which is equal to 250 milligrams. 250 milligrams require HCl, right? That is 250 milligrams required. Right? Then move on the next question. Match the following, right? So they give compound and also its geometry. NH3 is a trigonal pyramidal structure. NH3 is here trigonal pyramidal structure. That is what am I here? NH3 structure. We can take trigonal pyramidal structure like this, right? That is a BRFI is a square pyramidal structure. We have to BRFI we have to take square pyramidal structure. We can take like this. This is the square pyramidal structure. XCF4 is a square planar structure. XCF4 is a square planar structure. We can take like this square planar structure. This is a square planar structure. And SF6 is an octahedral structure. SF6 we can take like this. Octahedral structure, that is octahedral structure. So now we can check this A1, B4, C2, D3. Yes, option 3 is the correct answer. Then move on the next question. Right. The E0 value for the Mn plus 3 in Mn plus 2 couple is more positive than that of Cr3 plus and Cr in Cr2 plus or Fe3 plus in Fe2 plus due to change of Actually, E0 value is nothing but standard reduction potential value. Standard reduction potential value, Mn plus 3 changes to Mn plus 2. That is Mn plus 3 means 4s0, 3d4, 4s0, 3d4 changes to Mn plus 2, that is Mn plus 2, 4s0, 3d5, right? So Mn that is 3d4 to 3d5 means converting stable electronic configuration. See here, converting stable electronic configuration more positive than that of Cr plus 3 in Cr2 plus or Fe3 plus in Fe2 plus. That is D4 changes to D5 configuration. Right, getting stable electronic configuration, E0 values are more positive. Why? Because converting stable electronic configuration, that is a D5 configuration, right? Then go for here remaining this Cr plus 3 in Cr2 plus and Fe3 plus in Fe2 plus are less stable electronic configuration comparing with this. That is the reason why we can go with the D4 to D5 configuration is a more stable electronic configuration. E0 values are more positive. Then move on the next question. Match the following. Yes. Match the following. Isothermal process means iso means what? Same. Thermal means temperature. Temperature is constant. T is equal to 0. Isochoric process means isochoric delta V is equal to 0, right? V is equal to 0. And no heat exchange means Q is equal to 0. Carried out at constant temperature, V is equal to 0 in this process. Isobaric process, P is equal to 0, and adiabatic process, Q is equal to 0. Now please check here, no heat exchange, carried out at constant temperature. Yes, A is 2, you have to take. Isochoric process, B we have to take at constant volume. Yes, B we have to take 3. And adiabatic process we have to take no heat exchange, D1 you should take, right? So like this, finally A we can take, A is 2, right? A is 2, that is T at same temperature, carried out at the same temperature, constant temperature. And B is 3, that is what constant volume. Yes, constant volume we have to take, right? Then no heat exchange, that is adiabatic process, and carried out at constant, right? At constant pressure means isobaric process, that is C is 4, right? Then you can take option 2 is the correct answer, that is right. So that is isothermal process means T is equal to 0 at constant temperature, the process happening. Isochoric process, V is equal to 0, and isobaric process, P is equal to 0, adiabatic process, Q is equal to 0, right? Then move on the next question. Yeah, activation energy of any chemical reaction can be calculated by one knows the value of dash. Orientation of a reactant molecule during the collision, right? Rate constant at two different temperatures, rate constant at standard temperature, probability of collision. According to Van 't Hoff's equation, log of K2 divided by K1, EA upon 2.303 R into 1 by T1 minus 1 by T2, right? So according to Van 't Hoff equation, rate constant, here activation energy, calculation of activation energy, that is EA, rate constant at two different temperatures we can calculate by using this formula. Rate constant at two different temperatures, that is T1, T2 at two different temperatures we can calculate activation energy. That is option 2 is the correct answer. Option 2 is the correct answer. Rate constant at two different temperatures is the correct answer. Then move on the next question. A compound with molecular formula C6H14 has two tertiary carbons, the IUPAC name is dash. Your according to this formula, it satisfies alkane. It satisfies alkane formula. All bonds are single bonds between carbon and single bond, right? They are saying that two tertiary carbons, that means carbon attached with three more carbons is tertiary carbon, right? This carbon attached with three more carbons, right? So this is the two tertiary carbons. These two are the tertiary carbons, right? Tertiary carbons. So C6H14, right? Check once. 1, 2, 3, 4, 5, 6 carbons. Yes. C6H hydrogens how many? 3 plus 3 6. 3 plus 3 6. So here one hydrogen you have to keep. Here one hydrogen you have to keep. Total bottom H14, right? So this is the formula. Two tertiary carbons. So they are asking to find IUPAC name. So give the numbering here. 1, 2, 3, 4, right? So 2, 3 dimethyl, 2, 3 dimethyl. Root word is a 4 carbon chain, that is butane. 2, 3 dimethyl butane. So you can take option 1 is the correct answer. Option 1 is the correct answer. 2, 3 dimethyl butane, right? Then move on the next question. Spin only magnetic moment is same for which of the following is correct? Which of the following is spin only magnetic moment is same for which of the following ions, right? So magnetic moment depends on number of unpaired electrons. Magnetic moment we have to take magnetic moment mu is equal to root of n into n plus 2. Root of n into n plus 2 Bm. Bohr magnet. This is the formula to calculate magnetic moment. It is depends on n value. N value is nothing but number of unpaired electrons. Number of unpaired electrons. Right? So now we can observe here Ti3 plus means the electronic configuration. Argon 4s0, 3d1, right? 3d1. And chromium atomic number 24, that is 4s0, 3d4. And Mn2 plus, if you take Mn2 plus 4s0, 3d5, it is atomic number 25. Then Fe2 plus 4s0, argon 4s0, 3d6, right? Scandium is atomic number 21, 4s0, 3d0, both are 0, right? D0 electronic configuration, right? So same number of n value same means magnetic moment also same. N value same means magnetic moment also same. N value same where? So here 1 unpaired electron, here 1 unpaired electron, here 4 unpaired electrons, here 5 unpaired electrons, here 6 unpaired electrons, here 0 unpaired electrons, here 0 unpaired electrons. So according to our answer, so D6. Fe2 plus, we have to take Fe2 plus. So we have to fill electrons like this, right? We have to fill electrons like this 1, 2, 3, 4, 5, 6. That means unpaired electrons here, n is equal to 4 here. Here if you fill electrons here, so 1, 2, 3, 4 unpaired electrons. Here also n value 4, here also n value 4, right? So B and D having the same n value, right? So then we will go with option 3 is the correct answer. Option 3 is the correct answer, right? Then we move on the next question. Without wasting time. Arrange the following elements in increasing order of electronegativity. Very simple question it is. Electronegativity in the periodic table. Highest electronegative element is fluorine, then oxygen, that is 4.0 on Pauling scale, that is oxygen is 3.5, and next nitrogen is 3.0, right? right? This is the highest electronegative elements in the periodic table, right? So you can go with this order: fluorine, oxygen, nitrogen, fluorine, nitrogen, oxygen, right? So fluorine, oxygen, nitrogen, then carbon, then silicon. So we will take option 3 is the correct answer, right? Left to right, in periodic table, left to right, electronegativity increases, top to bottom electronegativity decreases. So this is the trend we have to remember, right? Then move on the next question. Which of the following alcohols react instantaneously with Lucas reagent? Lucas reagent, ZnCl2 plus concentrated HCl. This is the Lucas reagent. Test for alcohols. Test for different alcohols, that is primary, secondary, tertiary alcohols. Tertiary alcohol will give instantly within fraction of seconds give turbidity. Within fraction of seconds turbidity, within fraction of seconds give turbidity, within fraction of seconds it will give within 5 minutes. It will take very long time. There is no reaction also sometime, right? So tertiary alcohol we have taken in this given option. Tertiary alcohol, that is tertiary alcohol we have taken the OH attached with tertiary carbon is called tertiary alcohol, right? This is the tertiary alcohol will give instantly with Lucas reagent will give turbidity, that is yellow turbidity we are observing in this case, right? That is the question number 63, right? Then move on the next question, right? Then 64, statement type questions, right? Statement 1, both CONH3 plus and COF6 complexes are octahedral but differ their magnetic behavior. Magnetic behavior depends on number of n value, that is n value what number of unpaired electrons, right? So CONH3 plus, that is cobalt is plus 3 oxidation state here also cobalt plus 3 oxidation state, for CO3 plus, if you take electronic configuration 4s0 3d6 we have take 3d6, so the electrons are filled like this 1 2 3 4 5. So here NH3 is a strong field ligand, actually it is a strong field ligand. So the electrons are pairing takes place 1 2 3 4 5 6. So 6 electrons, n is equal to 0 here. Diamagnetic it is actually diamagnetic. N is equal to 0, diamagnetic here. Number of unpaired electrons are 0 here, diamagnetic. If you take same way F6 what am here, F6 is a weak field ligand, no pairing takes place. Same CO3 plus we have take 4s0 3d6. Here also we can observe like this. So 1 2 3 4 5 6. Here n is equal to we have take 4 here. It is a paramagnetic nature. Right? So here complexes are octahedral but differ their magnetic behavior as correct. So this statement is correct, right? Statement 2, CONH3 plus is diamagnetic nature, yes, correct. And also whereas COF6 is paramagnetic nature, yes, correct. This is also correct, right? Both are correct and correct explanation, correct. So option 3 we have take is the correct answer, right? Both the statements are correct. That is 1 and 2 is correct. Then move on the next question. Right? Then 64th question done, right? Then question number 65. Statement 1, the boiling point of hydrates group 16 elements follow the order, right? Actually boiling point top to bottom in a group, top to bottom increases, if you take oxygen hydrates H2O and H2S, H2SC, H2T TE. Top to bottom increases, top to bottom boiling point increases. We can take this is the correct order. But H2 in H2O intramolecular hydrogen bonding is there. So this one we can keep here. This one we can keep here, and this is the correct order for boiling point order, right? So they gave correct correct relation only. The boiling point order of group 16 elements of the following order is correct statement, right? And statement 2, on the basis of molecular mass, H2O is expected to have lower boiling point. Yes, boiling point also depend on molecular mass. Molecular mass also depends on molecular mass. More the molecular mass, more is the boiling point. So is expected to have lower boiling point than other members of the group, but due to the presence of extensive hydrogen bonding in H2O, it has higher boiling point. Yes, also correct, right? So both 1 and 2 correct statements. Both 1 and 2 is the correct statements, right? So boiling point order is correct, and also due to intermolecular hydrogen bonding, higher boiling point of water you can keep first in this case, right? That is option 3 is the correct answer. Then move on the next question. Question number 66. Match the following, right? This is a quantum numbers question. Quantum numbers here. Magnetic quantum number here. Magnetic quantum number, ML is magnetic quantum number. Magnetic quantum number gives information about orientation of orbital. Orientation of orbital it will give, and spin quantum number gives about orientation of spin of electron, and azimuthal quantum number L gives information about shape of orbital, and principal quantum number N is give size of orbital, right? So A is 3, B is 4, right? So C is 2, D is 1. Yes, option 1 is the correct answer. Right? Then move on the next question. Question number 67. Match the following reaction. Yes, organic chemistry they gave this. So they gave substrate and reagents, which is the correct relation, right? Here if you take here in this first conversion, this compound, if you break here, reductive ozonolysis, we can take here O3 in zinc in water, right? This is the correct relation. And in this case, acylation takes place here. This, yes. So you can take here you should take acylation takes place here. Benzene converted to biphenyls, right? Next, alcohol changes to ketone. That is secondary alcohol changes to ketone. Here oxidation takes place here. Oxidation is a CrO3 we have to take. CrO3, Jones reagent we have to take CrO3, right? Then CH2CH3 here hydrocarbon bond changes to acid part. That is strong oxidizing agent like KMnO4 we have to take. That is KMnO4 is the correct relation here. KMnO4, right? So D is 3 and C is 2, right? So then we have to take A is 4, right? A is 4. Option 1 is the correct answer. Right? This is the correct relation, right? Then question number 67. Then go move on the next question. 68. Identify the correct reagent that would bring about the following transformation, right? So it is a good question. Alkene changes to aldehyde. Oxidation takes place here, right? So if you take here option 1 BH3, this one they give, option 2 they give this, option 2 this, option 3 this, option 4 this, right? First if you take BH3, so in this H minus BH2 plus, H2 like BH2 plus, so H minus attack here, BH2 attack here in first step, boration. Next step oxidation we have to take oxidation means OH minus we have to take OH minus. Instead of BH2 we have to add here OH minus we have to add, OH minus we have to add. Next step we have to take for conversion of aldehyde, that is like this CH3 like CH2 CH2OH, that is boration oxidation, diboration oxidation. Next step we have to use PCC, pyridinium chlorochromate. Primary alcohol changes to aldehyde, pyridinium chlorochromate. So there is no ring, double bond here. CH2. So this carbon changes to aldehyde functional group, that like this. So there is PCC we have to use here, PCC, pyridinium chlorochromate. So then we have to take option 4 is the correct answer. First step is boration, next step is oxidation, and third step is oxidation. Third step also oxidation, that is using PCC, pyridinium chlorochromate. Primary alcohol changes to aldehyde, right? That is question number 68. Then move on the next question. Question number 69. The reagents with which glucose does not react to give the corresponding test products are dash, right? Here Tollens reagent means ammonical silver nitrate, AgNO3, ammonical silver nitrate, test for aldehydes, and also terminal alkynes we are using, right? So we are observing here, right? Here silver mirror test we are observing, silver mirror test we are observing here, silver mirror color we are observing here, fine. Ship's base we have to use like amine bases. HCN is a weak acid, okay fine. NH2OH and NaHSO3. So the reagent with which glucose, yes, glucose will give Tollens reagent test, and also HCN test we can observe, NH2OH test also we can observe. But in case of NaHSO3 and also Ship's base won't react with glucose, it is the properties of glucose, right? So these both are not reactive. Ship's base and NaHSO3 is what now, and weak one sodium hydrogen sulfite, weak one won't react with these both, right? That is option 1 is the correct answer. Right? Then move on the next question. Question number 70. Here just they asking to find the number of sigma and pi bonds. Very simple question it is, right? That is CH3 ethane formula, this one, and ethene formula we have like this, ethene formula, CH2 double bond CH2, ethene formula. Carbon molecule of O2, it is not O2, I think it is C2, carbon molecule of C2, it is like this. And ethane formula we have like this, right? See here, all are sigma bonds, one sigma bond, one pi bond over there. Here middle one sigma bond, two pi bonds here. Here also one sigma bond, two pi bonds, right? So single bond means what now, always sigma bond. Double bond means one sigma bond, other one is pi bond, and triple bond means middle one sigma bond, above and below pi bonds, right? Now you can choose the correct answer, one sigma bond and two pi bonds. Yes, C we can take one sigma bond, two pi bonds, and two pi bonds, one sigma bond and one pi bond. So here you can take A is 3, only sigma bond A is 3, and ethene one sigma bond and pi bond, one sigma bond and one pi bond. B we can take 4, C we can take 2 pi bonds, yes, 2 pi bonds we can take, 2 pi bonds. C we can take 2 pi bonds, and ethane we can take one sigma bond, 2 pi bonds, that is one we have to take, from here we can take 1 5. That is option 1 is the correct answer. Simple question, it is basic question, right? Then move on the next question. Right? Among group 16 elements, which one does not show -2 oxidation state? Actually -2 oxidation state means -2 oxidation state means Negative charge means gain of electron. How it is formed? Minus 2 means gain of 2 electrons gain. After gaining of 2 electrons, it will give minus 2 charge, right? That is actually gaining property we are observing for electronegative elements. That is for non-metals. That is for non-metals. So top to bottom electropositivity increases. Top to bottom electropositivity in groups, right? Left right electronegativity increases. Electronegativity increases in periods. Electronegativity increases in periods. Electronegativity increases in periods, right? Right. So among the group 16 elements, we can take group 16 elements, 16th group elements, that is oxygen, sulfur, selenium, tellurium, polonium. Top to bottom metallic nature increases, they cannot gain electron, so we can take polonium is the correct answer for this question. Polonium is the correct answer for this question because of to increase the electropositivity, you won't gain electron, right? That is option 2, polonium is the correct answer, right? Then move on the next question. Question number 72. For the reaction 2A changes to B plus C. Kc they gave at a given time the composition of reaction mixture is the concentration this much they give, right? So please write the QC expression here. For this reaction QC expression, QC is equal to concentration of B and concentration of C divided by concentration of A power 2. So if you substitute the values they gave here, equal composition, that is 2 into 10 power minus 3 into 2 into 10 power minus 3 divided by 2 into 10 power minus 3 whole square, 2 into 10 power minus 3 whole square, right? So minus 3, this square gets cancel amma. So then what will have? So this 2 get also gets cancelled, right? Right. So then QC is equal to 1 will come. Then Kc is equal to, they given here Kc they give 4 into 10 power minus 3. 4 into 10 power minus 3. We have few cases. In case 1, QC value greater than Kc. QC value greater than Kc means reaction more favor for backward direction, and QC value less than Kc. QC value less than Kc means forward direction, reaction more favor for forward direction, right? But in our answer, if you observe a QC value 1, Kc value 4 into 10 more minus 3, that is less. So that's what am I here? QC is greater than Kc, so reaction more favor for backward direction, right? That is option 1 is the correct answer. Right? Then move on the next question. Which of the following, which plot of ln k versus 1 by t is consistent with the Arrhenius equation? So we have Arrhenius equation, that is rate constant k is equal to a to the power minus EA by RT. From here apply log of k is equal to log A minus EA by RT. If you take graph here, log k versus 1 by t, so negative slope will get, that is negative slope will get, right? So option 2 is the correct answer. Because of it is a negative sign we have here, right? Negative sign we have, that is the reason why negative slope graph will get, that is option 2 is the correct answer. We'll move on the next question. Question number 74. In which of the following equilibrium Kp Kc are not equal? Kp Kc relation we have, Kp is equal to Kc into RT power delta Ng. Delta Ng is nothing but number of moles of gaseous product minus number of moles of gaseous reactants. If delta Ng is equal to 0, Kp is equal to Kc. If delta Ng is equal to greater than 0, Kp is greater than Kc. These are the conditions we have. Delta Ng is less than 0, that is Kp is greater than Kc, right? Now if you find out here for question number 1, here 2 minus 2 minus 2, 2 minus 2 which is 0. So Kp is equal to Kc in this case, right? In 2, like second option you can observe here, second option 2 minus 2, here also 2 minus 2, here also what am I 0, right? But here 2 minus 1 which is equal to 1, which is equal to 1, it is not equal, right? So not equal they asked, then you can go with option 3 is the correct answer. Here also 2 minus 2, here also 2 minus 2 which is equal to 0, here also equal to 0, right? So then our answer is option 3 is the correct answer. Then move on the next question. Very simple question they asked, like question number 75, statement type. The boiling point of 3 isomeric pentanes, follow the order. N-pentane, isopentane, N-pentane, isopentane, neopentane. So molecular formula same, just isomeric forms they give here. Actually boiling point directly proportional to molecular mass and also directly proportional to van der Waals forces, right? It is inversely proportional to branching, for isomeric forms, right? From branching, so more the branching, boiling point what less, right? So we can take N-pentane is C5H10, so branching increases, so boiling point decreases, right? So correct, this is the correct relation they give, right? Then we can take, when branching increases, the molecule attains shape of sphere. This results smaller surface area of contract due to which the intermolecular forces between the spherical molecules are weak, thereby lowering the boiling point. Yes, I think both are correct. You can take both 1 and 2 is the correct answer. The reason they gave here, the reason is the branching increases, molecule attains shape of sphere. This results smaller surface area of contact to which the intramolecular forces between the spherical molecules are weak. So it is actually what I said here, van der Waals forces. So as branching increases, van der Waals forces decrease, right? So that is the reason why the boiling point decreases for isomeric forms, right? Option 3 is that is both are correct. Then move on the next question. Question number 76. The compound that will undergo SN1 reaction with the fastest rate. SN1 reaction actually carbocation mechanism. That is stable carbocation. We have tertiary, like secondary, then primary. Before that we have benzyl and allyl, so on is there, right? So we can observe here phenyl chloride, here it is benzylic chloride. So then we can take option 2 is the correct answer. That will give benzylic carbocation will give, right? That is the correct answer, right? Then move on the next question. Question number 77. The energy of an electron in the ground state is minus x kilojoules. Then that for the electron in n is equal to state for B plus 3 ion in joules is very simple question. It is also, right? So actually, so E of He plus ion, they give minus x joules. Actually, E of He plus ion, we have formula minus 13.6 into z square upon n square. So this value they given here, is x joules. So if you substitute here minus 13.6 into z value 2 square by n is equal to 1, they give here 1 square. So from here minus 13.6 into 4 which is equal to minus x joules they give. If you take E of B 3 plus, so from here minus 13.6 into z value we have here 4 square. Divided by n value they gave here 2 square. Here. So from here minus 13.6 into, so 4 4 are 16 by 4 1s are 4 4s are, right? So which is equal to minus 13.6 into 4. So right, minus 13.64 into 4 minus 13.6 into 4 minus 13.6 into 4. Here this is minus x kilojoules. Here also it is also what? It is also x minus x kilojoules we will get. That's what we can go with. Option 2 is the correct answer. Option 2 is the correct answer, that is minus x joules, right? Then move on the next question. Question number 78, if you observe here, in which of the following process entropy increases? Entropy is nothing but the degree of randomness. Degree of randomness increases, entropy increases. If you take different physical states, solid, liquid, gases, if you take solid substances they are proper arrangement we are observing, then liquid, then gases particles are more rapidness, more randomness we are observing. So the particles are more randomness, more is the entropy, okay nana. S that is entropy order here, S is equal to solid state, then we have to take, then liquid state, then gas state, right? Gas state having the more randomness, that is more entropy. So here the given which is the correct answer they asking here. A liquid evaporates vapor, liquid changes to vapor, entropy increases. Yes, here entropy increases, fine, correct. The temperature of crystalline solid lower from 130 to 0 Kelvin, that is it freezes. So here we can decrease entropy decreases. Then NaHCO3, sodium hydrogen carbonate, solid changes to gases. Solid changes to gas means so solid changes to gas means entropy here also increases. And chlorine gas changes to like chlorine molecule changes to chlorine atoms. So atoms, molecule and atoms, if you compare here, atoms are more randomness here also increases. Then we can take AC, it is the correct answer. That is the according to our question. Then move on the next question. Question number 79. On heating, some solid substance changes from solid to vapor state without passing through liquid state. The technique used for the purification of such solid substance based on the above principle is known as, right? That is directly solid changes to vapor state. Solid changes to vapor state means direct without changing liquid state, right? That is sublimation. The process is called sublimation we have to take, right? Then move on the next question. Question number 80. Coordination chemistry question. Good question they gave here. Complex and its type of isomerism. CONH35 NO2Cl2 just here like exchange of linkage of NO2 and Cl2 we are observing here. Linkage isomerism we are observing in this case. A is 2 and we can observe in this case CONH35 SO4Br. Here we can observe here ionization isomerism, right? This SO4 comes out, Br comes out. Br going inside, SO4 comes out. So then go with the B is ionization isomerism. Then CONH36 CrCN6, right? Here exchange of ligands takes place here. NH3 and Cn, exchange of ligands, one complex to another complex. That is called coordination isomerism, right? That is option 4. C is 4. And water and Cl3, here hydration isomerism, that is solvent isomerism we are observing in this case, right? That is D is 1, A is 2, B is 3, right? C is 4, right? Option 3 is the correct answer for this question. Right? Then move on the next question. Question number 81. Statement: aniline does not undergo Friedel-Crafts alkylation reaction. Right? Is correct. Correct statement. How it is? Once look here. Aniline, if you take aniline does not undergo Friedel-Crafts alkylation. That means if you take CH3Cl in presence of AlCl3, so in this first step, generation of electrophile CH3 plus, so it will attack on the nitrogen. It won't attack on the benzene ring, right? So that's why aniline does not undergo Friedel-Crafts alkylation due to nitrogen due to NH2 group, right? That is a correct statement, right? Correct statement. Aniline cannot be prepared through Gabriel phthalate synthesis. Gabriel synthesis, that means aromatic amines we cannot prepare in this method. That is correct, direct statement we have, right? Both are correct and correct, both are correct statements, right? That is option 3 is the correct answer. Then move on the next question. Question number 82. Arrange the following elements in increasing order of first ionization enthalpy. Ionization enthalpy is nothing but the amount of energy required to remove the electron. Ionization energy or enthalpy is nothing but the amount of energy required to remove the electron from isolated neutral gaseous atom, right? So from valence shell of electron we need to remove from the atom, right? The required energy is called ionization energy. So that is actually, if you take trends, left right increase ionization energy, left right increase, top to bottom decrease due to metallic nature increase, electropositive nature here, electronegativity increases here, right? So we can go with if you take here in this given, nitrogen is the highest because of half field electronic configuration, stable electronic configuration. Nitrogen we can take, right? That is they give second period only, right? That is I will write here. Right, that is lithium, beryllium, boron. Second period they give here lithium, beryllium, boron, carbon, nitrogen. Left, right increase, right? So then go with nitrogen is highest, then carbon, then compare here 2s2 configuration, here 2p1 configuration. So here somewhat stable configuration we have. That's what beryllium you can bring here. Then boron, then lithium. Lithium is the least energy because of metal it is, right? That is option 4 is the correct answer. Right? Then move on the next question. Question number 83. Highest number of helium atoms, right? So number of atoms, for finding number of atoms we have number of atoms formula. That is number of moles into Avogadro number into atomicity. This is the formula to find the number of atoms. That means n value, number of moles increase, number of moles increase, number of atoms also increase more. Okay, number. So number of atoms more. Where number of moles more, just find out. So number of moles more, how to find 4 grams given mass upon molecular mass. That is 4 by 4. 4 by 4 means 1 mole we will get here. Here it is the given liters. They given here given volume at a STP. I think this is the STP. 2.27 divided by 22.4 liters. That is divide with gram molar volume. So it is also very less will come, less than 1 will come. So 4 moles directly they give here 4 moles. Here also 1 mole. Here also 1 mole we will get, right? 4u means here 4u means like 4 grams. 4 by 4, that is 1 mole will come. So 4 moles. So number of moles more, number of atoms also more, right? That is option 3 is the correct answer. Right? Then move on the next question. The most stable carbocation among the following. So carbocation stability what am? Tertiary. So carbocation stability order we have. Benzyl carbocation, that is resonance, right? The next allyl carbocation, then tertiary carbocation, then secondary carbocation, then primary carbocation, right? So we can observe here in this case which one is more stable. Here it is secondary carbocation, here it is also secondary carbocation, here it is primary carbocation, it is tertiary carbocation. Tertiary carbocation with we can observe here number of alpha hydrogens we can observe here 3 is there, total 7 alpha carbon hydrogens, 7 hyperconjugations we are observing here. More the hyperconjugation, more the stability. That is the stability of carbocation we are observing, right? So option 4 is the tertiary carbocation and more number of hyperconjugations we are observing. Here 5 we are observing, here 5 hyperconjugations we are observing. Here only 2 plus 1 3 hyperconjugations here. 3 hyperconjugations. So in this case, option 4 is the correct answer. 7 hyperconjugation, and so tertiary carbocation. Tertiary carbocation, right? Then move on the next question. Question number 85. The Henry's law constant values. Actually, Henry's law we have partial vapor pressure. Partial vapor pressure is direct proportional to mole fraction of gas. That means the solubility of substance in a gas is directly proportional to the mole fraction of gas. So which is equal to P is equal to kh into x, mole fraction. Here as temperature increases, kh value increase. As temperature increases, kh value increase. As kh value and solubility are inversely proportional according to Henry's law. So kh value increases, solubility decreases. So kh values we have kh order. A is more 145, A is more, then C we have take, then B we have take, then solubility we can take here, solubility we have take A, C, B, right? Then solubility we have take here, solubility opposite order, that is B, C, A, that is option 4 we have take. KH value and solubility inverse proportional, right? Then move on the next question. Question number 86. A complex contains 32% of A. A compound contains 32% of A. We can take A here. A, B, C. A they gave 32%, B they gave 20%, and C didn't give. Actually, 32 plus 20, that is 52. The remaining is C. Is how much? 48. So remaining C we have take 48%. We have take total percentage 100. Right? So divide with molecular weight, divide with atomic weight, we will get number of moles. So A they gave 64. Right? B they gave 40, and C they gave 32. So if you simplify this, 1s are 2s are 1 by 2, and this one also 1s are 2s are 1 by 2, and this one is 3 2s are 3s are, that is 16 2s are 16 3s are, right? So this is the so if now we can simplify this, multiply with 2, right? Just 1s are 2 1s are, that is 1:3 is the correct answer. That is the empirical formula we have to get. 1:3, that is A1, B1, C3. So that is the option 4 is the correct answer, right? For simplify manner, right? Next, go with the next question. Question number 87. The product A and B obtained in the following reactions respectively. This is the preparation of alkyl halides. Direct question. So PCl3, when we use PCl3, we will get here H3PO3. Here A is what? H3PO3. And if you take PCl5, the byproduct is here POCl3. Right? POC. The option 2 is the correct answer for this question. Then question number 88. The plot of osmotic pressure versus concentration for solution gives a straight line with the slope 25.73 liter bar per mole. The temperature at which the osmotic pressure measurement is done. Actually, the formula we have here, pi is equal to CRT. So pi by C is equal to RT. Pi by C value they gave here with the slope, straight line slope 25.73, which is equal to RT they gave, right? They are asking to find T is equal to 25.73 divided by R value they give here 0.083, right? 0.083. So from here we will get if we simplify this, 310 Kelvin we will get, So actually here there is no option in Kelvin, so we need to convert to Celsius. T is equal to 310 minus 273, So if you simplify this, that is 37 degrees Celsius is the correct answer. 37 degrees Celsius is the correct answer. That is option 3 is the correct answer, right? That is the option 3. Fine. Next, move on the next question. Question number 89. For the given reaction KMnO4 in H plus, very like a strong oxidizing agent, KMnO potassium permanganate in presence of acidic medium. So bond break like this here, bond break here. So this side was converted to oxygen, this side converted to acid, this side also converted to acid. So completely we are getting acid. That is option 4 is the correct answer. Completely we are observing in this option 4, right? So it is a strong oxidizing agent converted to what? It will completely break double bond. It converted to acid. 2 moles of acid will get here. 2 moles of acid will get here, right? That is option 4 is the correct answer. Then move on the next question. Question number 90. Statement NOC or like a complex CONH363 plus. CONH363 plus and is a homoleptic complex. When CONH34 is Cl2 is a heteroleptic complex. Homo means same, right? So here ligands NH36 same ligands. So here same ligand means it is a homoleptic complex, correct? That is correct statement. And here NH34 and Cl2 it is heteroleptic complex. Yes, statement 1 is the correct. Statement 1 is correct. Then statement 2, complex CONH363 plus as only one kind of ligands. Yes, correct. But CONH34 Cl2 is as more than one kind of ligands, correct? Yes, both statement 1 and 2 are correct. Right. Very simple question this. Let's move on the next question. Question number 91. Ferrous ammonium sulfate. NH4 twice, FeSO4 dot 6H2O. Right? This is the more salt. Here iron is in +2 oxidation state. During the preparation of more salt solution, ferrous ammonium sulfate, which of the following acid is added to prevent hydrolysis of Fe+2 ion? That is Fe+2 ion changes to Fe+3. So which for prevention of this process, which solution we need to add here? So that is they given options here: diluted hydrochloric acid, concentrated sulfuric acid, diluted nitric acid, and diluted sulfuric acid. So diluted sulfuric acid is the best option for this process. So due to remaining are somewhat more acidic nature comparing with this, diluted sulfuric acid we have to use for prevention of this process, right? That is the option 4 is the correct answer, right? Then move on the next question. Identify the correct statement. Chemical bonding question first here. That is NF3 is greater than dipole moment mu is equal to NF3 is greater than NH3. No, it is NH3 is greater than NF3 due to the direction of vectors. NH3 then NF3 direction of vectors, and also 3 canonical forms can be drawn for CO3 2 minus. Yes, correct. So canonical structures, that is resonance structures of carbonate ion we have like this. So the negative charge giving to next oxygen, this negative charge polarize all 3 oxygens, right? So we are observing 3 canonical structures for this carbonate ion, we can observe. That is the correct answer, right? And 3 resonance structures can be drawn for ozone. Only 2 resonance structures we are observing here, right? Only 2 resonance structures, that is wrong. BF3 has non-zero dipole moment. No, it is a zero dipole moment. So that's what we can go with. Option 2 is the correct answer. Then move on the next question. Question number 93. Yes, it is the recently newly added portion, inorganic quantitative analysis. Arrange the increasing order of group numbers 0 to 6. Actually, the given below certain cations, the group number we have actually magnesium we can go with. Magnesium is we have to take 6, and aluminum we have take so this one is 5. See, Ba2 place is Ba2 is 5, then CO2 place is 4, then A is this is the 3, aluminum is third group, third group number. Then we have to go with Cu2 place is a first group, right? So there is E, C, D, A, B. Yes, option 3 is the correct answer. Option 3 is the correct answer, right? According to our analysis, these are the group numbers while doing salt analysis, right? So next, move on the next question. 94th question. Identify the major product C formed in the following reaction sequence. Right here, Na plus Cn minus sodium cyanide. Cyanide here, Cn is a good nucleophile. So nucleophile substitution takes place here. I minus comes out. Right here, CH3, CH2, Cn. So it is partial hydrolysis. Partial hydrolysis will get here. Amide will get here. CH3, CH2, C double bond O NH2. C double bond of NH2. From here NaOH in Br2, that is a degradation takes place here. This CO goes out and we are getting here CH3, CH2, NH2, that is propylamine, 3 carbon chain amine. We are getting here in this process ammonia, one carbon, one amide group converted to amine group, right? So propylamine will get in this process finally C, that is. Then move on the next question. Question number 95. The rate of a reaction quadruples when temperature changes from 27 degrees Celsius to 57 degrees Celsius. Calculate the energy of activation. Yes. So we have actually now here Van 't Hoff equation log of K2 divided by K1 is equal to EA by 2.303 R into T2 minus T1 divided by T1 into T2. So by using this equation we can calculate activation energy. So they gave here the rate of reaction quadruples. This value they give 4. This value they give, that is log 4 is equal to EA upon 2.303. R value they given here. R value 8.314 into T2 they gave here. T2 minus T1, that is 57 minus 27, that is 30 divided by T1 is 27 means 270, 300, that is 300 minus 273 plus 57, which is 0. 330. This is 330. So from here we can simplify this. EA value will get here. 30.04 kilojoules. 38.04 kilojoules will get log 4 value by using substituting log 4 value. They gave here 0.60221. So that is option 3 is the correct answer. We will get here, right? Next, move on the next question. Question number 96. Consider the following reaction in sealed vessel. Equilibrium with concentration of N2 they gave here, O2 they gave here, NO also they gave here, right? So it is also simple question. Equilibrium Kc. So consider the following reaction. Equilibrium concentration of N2 they gave here. So K equilibrium is equal to product concentration divided by reactant concentration. So you can take here product concentration N2 O2 N2 3.0 into 3.0 10 power minus 3 and also O2 they gave O2 4.2 into 10 power minus 3 divided by 2.8 into 10 power minus 3 whole square
whole square. So just 10 power minus 3 whole square, 10 power minus 3, 10 power minus 3 gets cancelled. So from here K equilibrium will get here, equilibrium will get here, 1.06 will get here, 1.06 will get here. And according to our reaction, 2NO changes to N2 gas plus O2 gas, right? So at time is equal to 0, it is a C concentration, 0 concentration. At time is equal to time, that is C minus C alpha, this is C alpha, this is C alpha. Here stoichiometric coefficient 2 is there, by 2 we have take. From here Kc is equal to C alpha, C square alpha square divided by 4 into C square 1 minus alpha. So C square gets cancelled. From here if you substitute this K equilibrium value, this value here, if you substitute here, we will get here right. This one you can neglect here actually. So from here we will get so if you substitute K equilibrium value this here, alpha value will get here 0.717. If you substitute this Kc value, this one K equilibrium, right? So from here we will get 0.717. Option 2 is the correct answer for this question, right? So like this we have to observe question number 96. Then move on the next question number 97. Work done during the reversible isothermal expansion of 1 mole of hydrogen gas at 25 degrees Celsius from the pressure of 20 atmospheres to 10 atmospheres, right? So here it is also very simple question. Work done for isothermal reversible process, W is equal to minus of 2.3033 nRT log of P1 divided by P2. So from here we will get here minus 2.303. N value we have here, N value 1 mole they gave here, 1 into R value they gave here, 2 they gave, R value 2 they gave, temperature they gave here 25 degrees, that is 273, log of P1 divided by P2. P1 is 20 and 10, that is 20 divided by log of 20 divided by 10, that is 0 gets cancelled. Log 2 value we have 0.30. So from here if you simplify this, we will get here minus of 413.14 calories we will get. That is option 4 is the correct answer. Right? Then move on the next question. Question number 98. Mass in grams of copper deposited by passing 9.6487 amperes current through a voltmeter containing copper sulfate. Solution for 100 seconds. So actually this is the Faraday's first law. Number of moles N is equal to I into T divided by valence factor into 96,500, the charge of 1 mole of electrons. So from here N is equal to weight upon molecular weight is equal to I value they gave 9.6487 into time they gave 10 seconds, 100 seconds divided by valence factor for copper we have take a 2 valence factor copper we have take its valency, that is 2 into 96,500, right? So from here molecular weight we have weight by 63, molecular weight is 63, which is equal to 9.6. So we can simplify just 9.6487 into 100 divided by 2 into 96,500. So from here 20 gets cancelled. So from here, so here also this one gets cancelled, the 2 points. So the 2 points here we can keep 100 here. From here weight is equal to 63 divided by 2 into 100, which is equal to 0.315 grams we will get, right? So that is the Faraday's first law using can solve this formula, right? Then move on the next question. Question number 99. Major product A and B in the formed in the following reaction sequence. PBr3, it is a halogenation reaction. PBr3 halogenation reaction. Here in this OH place we can substitute Br, that is Br, right? Option 2. A is option 2, and B we have to take here. Sorry. Yes, Rana. Yes, option 1 is the correct answer here. Right? Here first step we have to substitute this Br here. Br we can substitute here. Here CH3 remains. And alcoholic OH, there is the E2 mechanism, Sedgwick rule, highly substitute double bond will get here, like this, right? Option 1 is the correct answer for this question, right? Then move on the next question, question number 100, last question. It is the F block elements, lanthanides. So lanthanides, the pair of lanthanides which are diamagnetic nature, that is N value 0 here, no unpaired electrons, N value 0 here. So please observe in this case, option 3 is the correct answer here. Why? Because option 3 here, cerium is cerium, the electronic configuration. So it is F0, and ytterbium is F14 electronic configuration. So here 0 unpaired electrons, here also 0 unpaired electrons. So here option 3 is the correct answer in this case, right? So this is the chemistry question paper analysis. So this year we may guess easy question paper, right? Okay, thank you everyone. Yes, all the best for your future. Thank you.